Yeah, hello viewers, welcome to my YouTube channel Mathematics Made Easy. So in today's video, I want to solve this beautiful mathematics problem. And here's the mathematics problem. We have integral from 0 to pi over 2 of arctan of square root of x dx. So I want to evaluate this integral. Okay, so if you are new to this channel, please don't forget to subscribe, like, comment, and also share. And if you are watching and you haven't subscribed, please kindly do so. Subscribe, like, comment, and also share. And don't forget to click the notification button so that anytime I upload video, you'll be the first to watch it. Alright guys, so let us waste much of our time. So let us dive into the solution. Now, how do we solve this problem? The first thing we are going to do is to make a substitution. Okay, so substitution in one sense. Now this is the square root of x. Okay, then if we make a substitution, we can say let's square root of x be equal to any letter you like. So you can make use of u, you can make use of t, you can make use of any dummy variable you like. So I'm making use of u now. So if square root of x is equal to u, then I can take the square of both sides to make x the subject of the formula. Then I have x is equal to u raised to the power of 2. Then we differentiate this with respect to u. So I have the x is equal to 2u, the u. Now check this problem. The limit is going to change. You know, this is 0 to pi over 2. So when x is 0, if you input 0 here, so we're going to have square root of 0, which is still 0. But when x is pi over 2, we input pi over 2 here, you're going to have square root of pi over 2. So the limit is going to change, all right? Then we have the following. So we have integral I equals integral from 0. So instead of writing pi over 2, then we're going to write square root of pi over 2, then arctan of. So instead of writing square root of x, we write u. Then instead of writing the x, we write 2u, the u. That is beautiful. So 2 is a constant, so we can bring it out. We have 2 multiplied by integral from 0 to square root of pi over 2. Then this is u, so we can bring it here. So we have u multiplied by arctan of u, the u. Now, so we have this. How do you think we can solve this beautiful problem? All right, so the best method we must use is the integration by parts. Is very straightforward, and that's the best method. Or if you don't want to use this kind of method, the integration by parts, you can make use of sum and series to solve this problem. Okay, but I don't want to go into the complex form of it today, so let us make use of basic calculus property, which is the integration by parts. All right, so to make use of the integration by parts, so I can let a be equal to arctan of u. All right, so if I let a be equal to arctan of u, then I can let the b be equal to u, the u. All right, then if you find the a, that is if you differentiate arctan of u, so we're going to have 1 over 1 plus u squared. Then if you integrate to get our u, all right, so to get our b rather, so we're going to have u squared over 2. all right, so let's just continue. So this will multiply this, and then this will also multiply this. You find the integral. So then we have I is equal to, don't forget this 2 outside here, so we have 2, then into, so arctan of u multiplied by u squared over 2, so we have u squared over 2 multiplied by arctan of u, then you apply the limit, okay, from 0 to square root of pi over 2, then minus integral from 0 to square root of pi over 2, then u squared over 2 multiplied by 1 over 1 plus u squared. Okay, so we have u squared over 2 multiplied by 1 over 1 plus u squared, then the u. All right, so if you apply the limit here, so we're going to have I is equal to 2, then into bracket. So if you apply square root of pi over 2 over u, then this is u squared, so square root of pi over 2 squared going to give us pi over 2. Then you are having over 2 here, so 2 multiplied by 2 will give us 4, so we have pi over 4. Then multiplied by arctangent of square root of pi over 2. Then if you apply 0 as the limit, 0 squared over 2 is 0, so definitely that would be 0, so minus 0, then you get this back. Okay, so minus then equal. See, this is 1 over 2 is a constant. We can bring it out. So we have 1 over 2 multiplied by integral from 0 to square root of pi over 2. Then we have u squared over 1 plus u squared the u. That's pretty cool. That's pretty cool. All right, guys. So let's move on. So the next thing we're gonna do is to deal with this integral. So how do we deal with this integral? So let me bring out this integral. So let me just call it integral alpha. So integral alpha, which is 0 to square root of pi over 2, then u squared over 1 plus u squared the u. Okay, so I can just say not just let, because this is a very important property that you must know. We can split u squared over 1 plus u squared. Okay, we can split it. So we know that u squared over 1 plus u squared, so this will give us 1 minus 1 over 1 plus u squared. That's very good. I've been using this identity in all my videos, like most of all my videos. If you are the kind of person that watch this completely, you see that this is not a new thing I've been using on my channel. Alright, so let's just move on. So instead of writing u squared over 1 plus u squared, we can just write 1 minus 1 over 1 plus u squared. So that will make the work too easier for us to solve. Though you can make use of other methods, but I prefer this because it's very easy for me. You understand? Alright, so let's just move on. So we have alpha is equal to integral from 0 to square root of pi over 2. So you have 1 minus 1 over 1 plus u squared. Yeah, so you have 1 the u, then minus integral from 0 to square root of pi over 2, then 1 over 1 plus u squared the u. So let's move to the new page. All right, now so you have alpha is equal to integral from 0 to square root of pi over 2, then of 1 the u minus integral from 0 to square root of pi over 2, then of 1 over 1 plus u squared du. I think that's where we'll start. All right, that's cool. All right, so if you integrate 1 du, so we are going to have u. Yeah, so we have u, then you apply the limit 0 to square root of pi over 2, then minus, and if you integrate 1 over 1 plus u squared du, so you're going to have arctan of u. So we have arctan of u, then also apply the limit 0 to square root of pi over 2. All right, so we have alpha is equal to, if we apply the limit here, so we're going to have square root of pi over 2 minus 0. Okay, so then minus, then you've also applied the limit here, so you're going to have arctan of square root of pi over 2. Then if you apply the arctan of 0, is to give us 0, so minus 0. All right, then we have alpha is equal to square root of pi over 2 minus arctan of square root of pi over 2. All right, that is cool. So I think we are done with alpha, so we should be able to complete the work. So let's complete the work. This is where we have, so we have I is equal to 2 into pi over 4 arctan of root pi over 2. All right, so we have I is equal to 2 into bracket pi over 4 multiplied by arctan of root pi over 2. Okay, then minus half of alpha, so which is square root of pi over 2 minus arctan of square root of pi over 2. All right, cool. So then we have I is equal to 2. If you open the brackets, 2 multiplied by pi over 4, so that will give us pi over 2. Yeah, that is what's going to give us. So we have pi over 2 multiplied by arctan of square root of pi over 2. Don't forget the square root is covering both pi and 2. Then minus 2 multiplied by 1 over 2 will give us 1. So minus times root pi over 2 going to give us root pi over 2. Then minus times minus is going to give us plus. So we have plus arctan of root pi over 2. So we can collect like terms. So this guy and this guy. So we have I is equal to pi over 2 arctangent of root pi over 2, then plus arctan of root pi over 2, then minus root pi over 2. So we can factor out root pi over 2 here. Then we have I is equal to pi over 2 plus 1, then multiply by arctan of root pi over 2, then minus root pi over 2, and that's the answer. So if you like, you can write out the approximated value. So the approximated value is 1.053581252.8. So that is the answer to that beautiful problem. Okay, so if you like this kind of video, please don't forget to subscribe, like, comment, and also share. So thanks for watching. See you next time. Goodbye.